In this video, we're going to look at t-tests. What is a t-test? A t-test is run when we want to compare the average scores, the mean, across two groups, such as male and female, with respect to gender. It only works for the mean though, that's only for interval or ratio variables. Why do we use t-tests? We run them when we want a test of statistical significance to confirm that the average scores of two groups are different. In other words, we can look at whether males have a greater purchase history than females. We can see this on face value by comparing the means, but a more rigorous statistical comparison is done through the t-test. This uses the numbers to reject a null hypothesis and statistically confirm that there is a distinction between groups. How do we run the t-test? We start with analyze, compare means, independent samples t-test. We're running an independent samples t-test as every case is a distinct individual. If we had data from people of multiple times, such as a longitudinal study, we should use a different test. But don't worry about that for this assessment. In the test variable now, we want to select the variable of the means we are going to compare. So this is what we're analysing, in this case, purchase history. Note we could do this for multiple variables at a time to improve the efficiency if we wanted to. Here we have purchase history. We then need to select a grouping variable, in this case, gender. We need to tell SPSS what groups we're comparing by selecting the Define Groups option and telling it that 1 is 1 and 2 is 2. In other words, 1 is female, 2 is male. Continue. This seems silly when we're analysing a variable such as gender in this data set that has got two groups. But if we're comparing means for a variable that has 3 or more groups, for example, the new age group we previously created, where we might only want to compare 2 of the groups within those 3, if we're doing that, we would need to tell SPSS what those 2 groups are. For example, we might want to compare group 1 with group 3. So we still need to tell it, even though it seems quite obvious, it can't read our mind. Now, to run it, okay, here we have our output. Now we get a bunch of output that tells us what the 2 groups are. Male and female, the variables, 1 and 2, the number of people in each group, the mean, standard deviation as well. Now these are important statistics that we use when reporting the findings of our results. What we can see is that the average purchase history was 20.16 for females and 21.60 on males. Now that doesn't seem to be that different in terms of size, but we need a more rigorous test, or in other words, a statistical test. So when we head down to the independent samples test table, I'll just make that a little bit bigger there. We need to look at the top or the bottom row. So in other words, equal variance is assumed, top row, or equal variance is not assumed. Now, to do this, we need to look at the F-score and its associated significance. If it is significant, i.e. if the figure for this is smaller than 0.05, which we can see it is here, it's 0.005, we then view the bottom row and ignore the top. You don't really need to know why we do this. It's just a statistical thing as part of the test. In the assessments, I won't penalise you for using either of the equal variances assumed or not assumed. But if you do want more information about this, Andy Field's 2009 textbook, Discovering Statistics Using SPSS, will talk you through why we do that. So we now move across a couple of columns to the significance t-tail test. This is the most important one for this one. And what we can see by looking at these figures is that, in this case, equal variance is not assumed. This is far greater than 0.05 as it's 0.223. This means that the two differences are not statistically different. In other words, on face value, yes, the mean of the males is greater than the mean of the females, but statistically there is no significant difference, and that should come into our decision making when we develop some recommendations or interpretations based upon these results. In the next video, we'll look at comparing it across 3 groups where we're using ANOVA.